The European honeybee, or Apis mellifera, has been introduced to many countries all over the world, including Australia, as a major pollinator of crops. Over the last several years, a phenomenon called colony collapse disorder, or CCD, has resulted in major losses to their population, a cause for serious concern considering how important the honeybees are to environmental sustainability. The occurrence of CCD has made investigation into the phenomenon necessary to preventing further losses, and while there are still no definitive answers as to why the bees are dying, there are several contributing causes which have been ascribed to the problem. While the global decline in bee populations is definitely worrisome, I was particularly interested in the effects of CCD on Australian bees, because even though there is some controversy surrounding Australia's European honeybee population, they are currently the primary pollinators of many Australian crops. In order to better understand the reasons for and ramifications of the honeybee population loss, I first had to work out what to look for. This led to a preliminary search of Google using select keywords including bee, population, decline, and Australia, and was furthered through more restricted searches of Google Scholar, JSTOR, and the Curtin University Library eReserve, with additional keywords including colony collapse disorder, neonicotinoids, and varroa. The information gathered helped to build a foundation for my inquiry. However, much of it was quite broad and not restricted to Australia, or was too old. Fortunately, the general information was enough to give me an idea of what the major concerns are regarding the declining bee populations, and even with the lack of discrete information about Australia's European honeybees, I was able to conclude that, like the rest of the world, Australia's honeybee population is most at risk of CCD because of varroa infestation and the use of neonicotinoids, or neonics. However, unlike the rest of the world, Australia's honeybees are actually doing quite well. In fact, our bees are the healthiest in the world. That doesn't negate the risk, though. Neonic pesticides are used in Australia, and if used incorrectly or in the wrong area, can do serious damage to the bees. As neonics are absorbed into plants, the bees don't just inhale or touch them, they ingest them, and it is suspected that they are the cause for several complications, including not returning to the hive, disorientation, abnormal foraging behaviour, and increased sensitivity to disease. The other major threat to bees, the varroa mite, is a known carrier of diseases, and much like a tick, feeds off the honeybee's blood. European honeybees are particularly susceptible to negative effects of varroa, and hive infestation can lead to deformations in bees and, if left untreated, the death of the hive. As of 2016, Australia has remained varroa-free, with the exception of one case in Townsville. The fact that Australia has gone unaffected by colony collapse disorder means that the best response to the problem is prevention. As neonics are used the same way in Australia as in other countries, the best option to prevent the same problems occurring is to change how and where they are used. In regards to prevention of varroa mite infestation, Australia already has biosecurity measures in place to prevent and control varroa outbreaks by adhering to strict importation laws and cargo checks. There is also research being done into genetically breeding more resistant bees, and also a program in which tiny sensors attached to the honeybees are helping scientists to map the activity of the bees with the intention of using the collected data to develop a better understanding of their activities and behaviour. As part of the Australian curriculum, this subject would be a good one for 4th grade students to investigate, as it can be attributed to several areas of the science curriculum and has aspects relating to almost all of the cross-curriculum priority for sustainability areas. Links to the science curriculum include Science as Human Endeavour, which relates to understanding human impacts on the environment, especially in relation to pesticide use and introduction of non-native species. Science Understanding, which connects relationships between bees and the environment, particularly the pollination processes and effects of pesticides. And Science Inquiry Skills, which relates to the investigation elements including research and topic development. The links to the cross-curriculum priority for sustainability include systems as it pertains to the bees' relationship with the environment and the sustainability of the ecosystem, worldviews as it relates to understanding the importance of bees to the ecosystem and issues associated with CCD and what can be done to prevent further problems, and futures, which relate to human responsibilities in not only the cause of the issue but also of the solution.